This is Chapter 1, Section 2. You should have your guided reading out. That's pages 3 and 4 of the guided reading. Once again, do the reading strategy at the end. So this is about the spheres of the earth, the major spheres. Now, a sphere doesn't necessarily mean that it's round. It can mean a cycle also. So with this, we're going to talk about the major spheres. The first one is the hydrosphere. Hydrosphere is why the Earth is called the blue planet, because it's the most prominent feature on the Earth. 71% of the Earth is covered with water. Okay? And the hydrosphere holds 97% of the Earth's water. The rest of the water is locked up in rocks and clouds, things like that. But this also includes fresh water, all the groundwater, all the water vapor that's in the air, the oceans, streams, rivers, springs, creeks. All of this, ice, glaciers, all of this is part of the hydrosphere. The next major sphere on the Earth is the atmosphere. Now, if you look at the atmosphere like from a picture from space, it looks very thin, and it just is a blanket that covers the Earth, and it stays in place because of the Earth's magnetic field, which shields it from the solar wind. If that wasn't there, our Earth would be more like Mars. Mars doesn't have nearly as strong of a magnetosphere, and so the solar wind has blown a lot of Mars's atmosphere away. And that's what's currently happening to Venus. So we're fortunate that we have that. 1/2 of the air in the Earth's atmosphere is below 3.5 miles. That's 5.6 kilometers. That planes fly higher than this. That's why when you get above a certain elevation, it gets harder to breathe. You go up to Big Bear, California, and you go for a run, it's much harder because you're up higher than you are down here in Redlands. The third sphere is the biosphere, and this encompasses all of life, whether it's in the air, in the ground, on the ground, in the ocean, or even, like a couple miles there below the Earth's surface, they still find bacteria. It includes all of these things. And the fourth sphere is the geosphere. This is the rocky part of the planet. It's the crust, it's the mantle, and it's the core. The core is the innermost part of the Earth, and it's divided into inner core and outer core. The mantle is divided to the mantle and the upper mantle. And the crust and part of the upper mantle combined together forms the lithosphere. This is where plate tectonics happens. So if you look at the diagram here, you can see the relative thicknesses of each of the layers. The crust is very thin, 5 to 7 kilometers. That's like 3 miles in the thinnest part. The upper mantle and the lower mantle together are 2,890 kilometers, so that's a lot. And then the outer core and the inner core. If you look at the little excerpt over on the right, it shows the lithosphere, and that the lithosphere gets thicker under mountains, thinner where there's oceanic crust, and it rides on the asthenosphere. Okay, so the asthenosphere is a more liquid part of the upper mantle, and this is what allows the plates to move. Plate tectonics is one of the biggest topics that we cover in earth science. Now, you may know some things about plate tectonics, but we're going to go deeper. We're going to talk about forces that are involved in plate tectonics, as well as how do we even know it's there? What's the evidence for it? Where did this idea even came from that continents are moving? Even now, if you're sitting down, things aren't moving, but yet they are. North America plate is moving a little bit faster than what your fingernails grow, and it's moving to the west, which is why California has earthquakes. That's why California, Oregon, and Washington state have a lot of volcanoes. And so this is also why there's so many mountains in these western states also. Even the mountains, the Rocky Mountains in the central part of the United States, was formed by plate tectonics. And this concludes section 2 of chapter 1.